Hello students, in this video we'll discuss several consequences of Gauss's Theorem of Egregium. So recall we have the Theorem of Egregium. And the Theorem of Egregium of Gauss states that curvature, Gaussian curvature, is invariant under local isometries. Okay. And furthermore, it gives us a formula for the Gaussian curvature in terms of the Christoffel symbols, right? It tells us that E, so let's do it like this. So let's suppose we have a surface. So suppose that S has first fundamental form, a special type of first fundamental form, where the F term is missing. So it just looks like E du squared plus G dV squared, okay? If that's the first fundamental form of the surface, a special case, then the Christoffel symbols simplify dramatically, right? And gamma 1, 1, 1 is equal to EU over 2E. Gamma 1, 1, 2 is EV over 2E. Gamma 1, 1, 2 is negative EV over 2G. And then gamma 2, 2, 2 is GV over 2G. Gamma 2, 1, 2 is going to be GU over 2G. And then gamma 2, 2, 1 is going to be negative GU over 2E, like that. So the Christoffel symbol is simplified dramatically in the case when you have a first fundamental form that looks like this. And furthermore, we have an equation for the Gaussian curvature in terms of E and the Christoffel symbols. And we know that E times K, this is exactly one of the consequences of the Theorem of Egregium, is going to be gamma 1, 1, 2 V minus gamma 1, 2, 2 U plus gamma 1, 1, 1, 1 gamma 1, 2, 2 plus gamma 1, 1, 2, gamma 2, 2, 2 minus gamma 1, 1, 2, 1, gamma 1, 2, 2. And then there's a 1 down here actually. So 1, gamma 1, 1, 1. And then minus gamma 1, 2, 2 quantity squared. Okay, there's our formula for the Gaussian curvature. Okay, so let's fill in what these things are going to be, right? So we have E times K. E times K is going to be gamma 1, 1, 2. So gamma 1, 1, 2 is over here. It's going to be negative d by dv of EV over 2G. Then gamma 1, 2, 2 is over here, right over here. It's going to be minus d by du of GU over 2G. Great. And then gamma 1, 1, 1 is EU plus EU over 2E. And then gamma 1, 1, 2 is over here. It's going to be a GU over 2G. Great. Then plus gamma 1, 1, 2. Gamma 1, 1, 2 is going to be a negative EV over 2G. And that's going to be multiplied by the gamma 2, 2, 2, which is going to be a GV over 2G. Great. And then what? And then we're going to have a, over here, a negative gamma 1, 1, 2. Gamma 1, 1, 2 is this thing over here, so negative EV over 2E. And then gamma 1, 1, 2 is going to be a negative EV, so it's a plus EV over 2G, like that. Great. And then a minus gamma 1, 2, 2, GU squared over 4G squared, like that. Beautiful. All right, so now we're going to have to do some simplification over here. So what's the simplification we're going to do? So let's do the quotient rule over here. So this is going to be a negative, and then it's going to be a bottom times, I'll put that 1/2 out in front, 1 over 2 with a negative sign, right? And then we'll have what? We'll have a bottom times the derivative of the top. So it's going to be a GEVV minus the top times the derivative of the bottom. EVGV over G squared, like that. Great. Over here we have a minus what? We have a minus, pull out the 1/2 again. And then we have a g bottom times the derivative of the top times GUU minus top times the derivative of the bottom, GU over g squared. Then over here we're going to have a EU GU over 4EG. And then over here we're going to have a minus EVGV over 4G squared. Over here we're going to have an EV, so plus EV over what? Over 4EG squared, EG, and minus GU squared over 4G squared, like that. Great. Okay, now I'll simplify some of these terms over here. So now what I'm going to do is I'm going to do the following. I'm going to do a negative 2. So everything is a factor of this 2 over here. So I'm going to do a negative 2 what? Negative 2 square root of EG times K. Okay, so that's going to give me a what? That's the equivalent to multiplying everything in here by a negative 2 by a 1 over root G, by a, so really taking this equation over here, and what are we scaling it by? We're taking this equation over here, and we're scaling everything, so I have this expression over here, so I'm missing an E, right? So if I'm missing a root E over here, I'll have to put a root E on both sides of the equation, right? So I have a root E over there, great. And then a what? And then a over root G. Okay? And then a 1, then multiplied by 2, okay? Excellent. So in other words, what effect are we doing by taking this equation over here? We're taking this equation over here, we're multiplying this equation by 1 over root E. So in other words, what we do, let's be a little more careful about that. So we're taking this equation over here, and we're going to multiply by 1 over root E. That'll give me a root E, a 1 over root G, okay? And then by a negative 2, right? And that will give me exactly what we want, right? And then times a root G, actually. So we're going to take this equation over here. Let's be a little more careful. Let's see, I'm going to take this equation over here. I'm going to multiply by negative 2. I'm going to divide by a root E. That will give me a square root of E, and then multiply by square root of G. Okay? And that'll give me exactly what I want. So we're going to do the same thing over here. So all the negatives are going to turn into positives, right? And so what will happen over here is this is going to turn into a what? That's going to turn into a root G over root E. So that's going to be a, let's do it carefully. So the 2 is going to go away, so I'm going to have a root G over root E times an EVV over a single G, and then minus an EVGV over G squared. And then over here, the 2 is going to go away, right? And so one of the G's is going to cancel out, so we're going to have a plus. This is going to be a root G over root E, and then we're going to have over here the GUU is going to be a GUU over G minus GU quantity squared over G squared. Okay, excellent. And then what's going to happen over here? This term over here is going to be a negative EU GU over what? Over a factor of e to the 3/2 and then root G. So that's going to be e to the 3/2 root G, and then there's going to be a factor of 2. So 2e to the 3/2 in the denominator, and then a square root of G. Over here it's going to turn to a plus EVGV over what? I'm going to have a 2 root E, and then G to the 3/2 power. Over here I'm going to have a minus EVEV over what? Over 2, and then the E is going to be a 3/2 power, and then the G is going to be a 1/2 power. Good. And then over here we're going to have a what? Negative G, positive GU squared, and then over what? Over the square root of E times 2, and then a G to the 3/2 power. Excellent. Okay. So let's look at what terms are going to cancel out over here. So this first term over here, so this is exactly going to be equal to what? This is exactly going to be equal to, this first term over here is going to be, there's a single G over here, so this is going to be an EVV over root EG, root G, okay? That's that first term. This term over here is going to stick around. That's going to be a GUU over root E root G. That term is over there. Now I have an EVVGV and EVVGV over here, right? Over here. And then over here, I have a GUU over here, and then a GUU over here, right? So those terms are going to wipe out with each other up to a factor of 2. And then, so what will we have over here? Then we're going to have a total factor of what? So in other words, some of these factors are going to cancel out. So let's look at this term over here first. So that's going to be a negative. These terms are equal and opposite, except that I have 2 of them over here. So what we're going to have over here is we're going to have a negative 1/2 EVGV over, I'm going to write it like this, write it as root E and then G to the 3/2 power. Good. That takes care of those 2 terms. These 2 terms over here are going to cancel on equal and opposite terms. There's going to be a negative 1/2 GU squared over root E. And then I'm going to write E root G times G like that. Excellent. And then what's left over are these terms over here that didn't get touched, right? That's going to be in minus EU GU over 2E to the 3/2 power root G, and then minus EV over 2E to the 3/2 power G to the 1/2 power. Excellent. And now, of course, we have the structure of the chain rule over here. So what we really see over here is have a look at this term over here, and then these 2 terms over here. Those correspond to what? That corresponds, the derivative of EG, the derivative of EG square rooted is 1/2 EG to negative 3/2 powers, which is exactly what we see in these denominators over here, right? With these extra 3/2 powers, which is perfect. So in other words, what we have is the following. So in other words, this expression over here, so hence K, is going to be what? It's going to be negative 1 over 2 square root EG by dividing by this expression over here. Then this term over here is going to group with this term over here and this term over here. And those terms give me a cumulative factor of what? Of the V derivative of EV over the square root of E times G. And then these terms over here, this term over here, and then this term over here, and this term over here, exactly grouped by the product will give me a what? Plus d by du of what? Of GU over the square root of EG. And this is our formula over here for the Gaussian curvature. This is our Gaussian curvature in the case when the middle term in the metric is equal to 0. We're going to make further simplifications of this, of course, in the case when E is equal to 1, this is going to reduce to what? This is going to reduce to the standard formula that we have, the negative 1 over what? And the negative 1 over GUU over root G, basically, right? So we get this really beautiful formula when this breaks down in the case when E is equal to 1 and when G is not equal to 1, we get this sort of the more elementary formula in terms of finding Gaussian curvature in terms of the square root of the function G. Thank you very much.